Hi and welcome to Algebra 1. This is Chapter 1, Section 6, Multiplying and Dividing Real Numbers. Okay, so if you watch the other video, you would probably already know that when you multiply a positive times a positive, you'll get a positive answer. And when you multiply a negative number by another negative number, you'll get a positive answer. That's kind of nice. Now, same thing happens with dividing numbers. If you have two positives, if you divide a positive by a positive, it's kind of obvious. We already knew this. This is a positive answer. And if you have a negative divided by a negative, you have a positive answer as well. So the nice thing about this is that we can now, let's put a positive here. Anything that you're dividing or multiplying, when you have the same sign, you end up with a positive. Now, when you have a negative times a positive, it equals a negative. So basically we have different signs multiplied together give you a negative. And the same thing works for division. When you divide numbers that have different signs, you end up with a negative. So let's put a big old negative here. It's kind of nice because these rules are getting clumped together and don't have to remember so many. Now, let's have a look at these examples. I tell you, these examples, people get these mixed up all the time. So let's see what the mechanics are involved in these numbers here. So first thing we want to do for this first example is it says it's negative 3, and that's to the power of 2, so negative 3 squared. The way you would show work with this is you would write negative 3 in parentheses, and then negative 3 in parentheses again. So now what we can see is we have a negative times a negative, same sign, so it's a positive, and then 3 times 3 would give us 9. So the answer is positive 9. Now let's have a look at the next example. I don't know if you know this, but the negative doesn't actually belong to the 3. There's actually a negative 1, which is invisible. The 1's invisible. So this is actually negative 1 times 3 squared. Now let's have a look at this. When we have negative 1, and then it's multiplied times positive 3 squared, we have negative 1 times 9. And as you can see from above, when you have a negative times a positive, your answer is negative. So, what's 1 times 9? Yes, you're right, it's 9. So, our answer is negative 9. This is the most common mistake that I see because people don't understand the mechanics involved in this question. So, be careful. The next thing I'd like to look at is what this plus minus means. Now, we just got done saying that when you have a positive and negative, they're different signs, so it becomes negative. But in this case, a positive and negative actually means there's two answers. So I'm going to write that down. It means that there's two answers. So if you have a question that starts out with, for example, what's the positive and negative answer of the square root of 144? Well, you know what the square root of 144 is, don't you? Yes, I knew you knew. And that would be 12. But remember, it's asking you for the positive and the negative answer. So really, this is a shorthand way of writing positive 12 and negative 12. Now, you can write them out separately if you like, but I tend to like putting the positive and negative there. Okay, the next thing I want to talk about is the multiplicative inverse. Now, it sounds really fancy, but really all it is the reciprocal. When you have the reciprocal of two real numbers, and they have to be non-zero, A over B, so it's one number over another. To find the reciprocal, all you need to do is flip these. So, flip the A and the B, and you'll get B over A. Oh, that seems very simple. You've probably done that a lot when you've done division problems and fractions. So, let's see, what's the reciprocal of negative 2 over 3? Yes, you probably guessed right. It's 3 over negative 2. And I'll tell you a little secret. That negative, it floats. So it can sit in front of the 2, it can sit in front of the negative, in front of the 3, or it can sit in front of that fraction bar. The next one I want to have a look at is, what's the reciprocal of 1.5? You're going, well, hang on here, it's not in that form of A over B. So what we need to do is we need to turn it into an improper fraction first. So we're going to turn it into 3 over 2, and I'm sure you know how to do that. You multiply the denominator times the whole number, and then you add the number up top. So that would be 3 over 2. And then to find the reciprocal of that, all you need to do is reverse or flip the 2 and the 3. So there we go. If you're stuck with a mixed number, then it's easy to fix. The next one I'd like to show you is you'll have a question on homework tonight that says find the value of the expression x over y, and they'll give you 2 fractions or maybe the mixed number or something. So the first thing you need to do is you need to take the 3, the 2 over 3, and you need to plug that into where the x is, and then you need to take the negative 4 over 9 and plug it in where the y is. So it ends up looking very complex. So 2 over 3 over negative 4 over 9. And that is actually called a complex fraction, but it's really not that complex at all. So you've done lots of these, you just may not recognize it. So it's 2 over 3 divided by negative 4 over 9. Now it looks familiar, doesn't it? And we need to remember to keep the front fraction the same, change the division sign to multiplication, and find the reciprocal or multiplicative inverse of negative 4 over 9. Okay, and it looks like there's some things I can cancel here before I multiply it out. 3 goes into itself once and into 9 3 times, and then 2 goes into itself once and into this with a negative. Okay, now let's look carefully as we multiply across the numerators. 1 times 3 is 3, and if we multiply across the denominators, 1 times a negative 2 gives us negative 2. Now again, that negative can float, so it would be the same as having negative 3 over 2, and it would be the same as having the negative in front of the fraction bar with the 3 on top and 2 underneath. So get used to seeing all those different types of fractions where the negatives moved around, because they're basically all the same thing. Okay, so when I first came over to the States, I asked, well, what's the temperature? And they said, well, it's, 50 degrees. And I'm going, 50 degrees? Wow, that's really hot. Of course, they were talking Fahrenheit and I was talking Celsius. We use Celsius in Australia. So if I was to ask you, what's the temperature in the middle of Australia if it measures 40 degrees Celsius? And you probably go, I'm not sure. But let me see if I can find a formula to figure it out. Oh yes, there it is. It's Fahrenheit. So if you want to talk the same degrees to someone, Fahrenheit equals 9 over 5 C, where the C stands for Celsius, plus 32. Okay, well that's pretty awesome. Now I can take my 40 degrees and plug it in here. And we should be able to figure out what is this 40 degrees Celsius in Fahrenheit. So let's replace the C with 40. And notice I'm making the 40 about as big as the 9, and I'm going to put it over 1. Now, this turns out to be rather nice, because if we cancel out the 5 with the 40, we'll end up with 72 plus 32. Whoa, that seems like it's an awful lot. And then when we add this together, we'll get 104. Yes, folks, 40 degrees Celsius is 104 degrees Fahrenheit. Yes, it's awfully hot in the middle of Australia. It is desert after all. But basically, that's all you need to do for your homework question. Thanks for listening. We'll see you next time.